welcome to video 2 on audio excursion series, where we are going with diarization this time. So last time we talked about how you can take an audio and using a whisper model. We went with large whisper model where this model was on local machine. You could use this to convert an audio into text, but that text audio itself did not have any understanding of who the speaker was, and there could be multiple speakers in an audio. Whisper would not do any diarization for you. So what does diarization actually mean? So when there's multiple speakers, when you're doing a meeting or you are at a concert, probably not at a concert because that's where our model will actually start to fail a lot because there's a lot of conversation going on. But let's say there's a conversation happening between two people, and one person is speaking and the other one is silent. So what you could do with diarization is you could record and understand which speaker is the one that's speaking, and thus classify in the audio itself, and like afterwards the transcript itself, to figure out who was speaking. Where would you use this? The best places that people have found uses for this is in the meetings and conferences, of course, podcast and interviews where you want to figure out you versus the interviewee. Similarly, in the legal proceedings where you have to know exactly who said what. Same in the market research, call centers, and other use cases. So how would you start using this? We will build on top of Whisper what we already have on a large model here, and we will be adding a pi note on top of it. Pi note is useful for speaker diarization, where it will take the audio that we have and feature extract from it, where it will do speech activity detection. Then it will detect from that where is the changes happening, because there could be silences in here, and then it will try to identify when the speakers are changing, and then it will put that into an embedding space where it can tell that there are multiple speakers and how the audio is changing between those speakers. And then finally it will cluster those, so you can see 3 different audio segments in here, or 4 or 5 different audio segments where you can see each speaker speaking different things and over the timeline in here. To start using this, it essentially ends up using some of the models that are on Hugging Face by the same project group. So you have to actually go in and agree to share your contact information with the model. You have to do it for both of these. If you don't, as you're using it, it will prompt you to do that. So of course it will also use the Hugging Face endpoint, and you will have to use the Hugging Face token in here as well. So how do you start using this? So we remain the same as on Whisper side, but we add 2 new packages in here, PioNote and SpeechBrain. SpeechBrain is also required because PioNote is using it internally. I found out that SpeechBrain's default installation does not work. This is the most recent working package that I could find for this. After that, we just import everything. This time we have a few more imports in here. I'm going to be using pandas for CSV conversion, and I have a Hugging Face token in here which is hidden right now, and to include that, because we'll be making calls to Hugging Face, we need this Google Colab package. And of course we are using PioNote and SpeechBrain in here to run the pipeline which will be extracting the speaker information. So as before, we get the device, see if we have a GPU available. In this case we do. Load the model to the GPU, and then load our pipeline, create our pipeline for speaker diarization as well. And in here we are passing in this Hugging Face API key. So this gives us the pipeline, and both of things are ready. Now our model is ready on one side, and our pipeline for speaker diarization is ready. So then this is a function, second function to diarize audio, and then in here we first do the transcript, then we do the diarization, and for both of those we are just passing the audio path. All the other examples are same from the previous video. And then we get the segments, and for each segment we are trying to figure out the speaker is present in here. So there's 2 for loops happening in here. This is probably not the great way to write this function, but essentially this is a nested loop in here where we first get the tracks from the diarization, and then we find the speakers in those tracks and add those in here. Finally we put all of this into a data frame and write down to CSV. Let's see how much time it takes. This is a long enough file in here for this diarization. It takes 239 seconds to do this, both operations of getting the transcript as well as the diarization. And finally, you can see in the CSV file that we have start, end, as well as the speakers. So this is speaker 2, this is speaker 0. I don't know why I didn't do a speaker 1, but here we go. And it's a fairly normal conversation where the person 1 goes, I managed to keep up with all the assignments, but I'm not sure how to. And then the speaker 2 interjects with how to review everything. So yeah, this is how it works. Hopefully it's useful for you. And yeah, if you are building something around these use cases, this would be a really good thing to put into your models or put into your pipelines. Thank you so much. Yeah, let me know what else would you like to see. I'm looking into different problems around noise reduction, accent recognition, vocabulary, where you have custom vocabulary and you want to include it into your models. So let me know what you would like to see next, and I'll see what I can build in on that. Awesome. Thank you, everybody. Have a good day.